This will be for the Kuta software worksheet, arcs and chords. So a few theorems you need to know before we get started. If one chord is a perpendicular bisector of another chord, then the first chord is a diameter. So you can see in the diagram here, SQ is perpendicular to TR. It makes a right angle. So these two segments are perpendicular. Also, SQ bisects TR. Here's TR. We can see this piece is congruent to this piece here. Okay, so TR is being bisected by SQ. Since it's perpendicular and it's bisected, that means SQ is a diameter. If a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. All right, so we have to assume that this is the center right here. And this chord that passes through the center is a diameter. And we can see here this diameter makes a right angle with this chord right here. So EG and FD are perpendicular. So since this is a diameter and it's perpendicular, it's bisecting this chord. Therefore, FH is congruent to HD. FH is congruent to HD. All right, because it's being bisected. Finally, I'm not sure if we'll use this one, but in the same circle or congruent circles, two chords are congruent if and only if they are equidistant from the center. So when you measure distance from a point to a line segment, it has to be perpendicular. It has to make a right angle. So they're saying AB is congruent to CD. That's this chord and this chord here, if and only if EF equals EG. So this here has to equal this here. They have to be the same distance from the center, and that makes them congruent. All right, find the length of the segment indicated. Round your answer to the nearest tenth if necessary. That's 1 decimal place. All right, let's look at number 1. I'm assuming if there's a dot in the center of the circle, we can assume that is the center. All right, so if we were to draw a line from that point, a line segment from that point to the circle itself, that would be a radius, okay? And of course, if you kept going, if you extended that, that would be a diameter, all right? And they said if a diameter is perpendicular to another chord, and we can see this as another chord, that means the chord is being bisected or cut in half. So this is congruent to this, all right, since it's perpendicular and this is a diameter. So nothing to calculate. X equals 6. All right, number 2 is going to be done the same way. All right, number 3 is easier than it looks. We can see right here, this is the center and a segment or chord that passes through the center is a diameter. So this length right here is a diameter. And this right here, since it goes from the center to the circle itself, that's going to be a radius. All right. And we know that the radius is half of the diameter. All right, and the radius here is going to be 7 plus x. So in place of r, that's going to be 7 plus x, and that's going to equal half of the diameter, or half of 31.8. All right, so I'll let you finish that from there. All right, same thing, similar thing with number 4. If you start at the center and go to the circle, that distance or length is going to be a radius, okay? And no matter where you draw the radius, it's going to be the same. So this is 9.7, and this plus this is also 9.7. 5.1 plus x equals 9.7. All right, same with number 5. This is a diameter here. You take half, and that's going to equal 4.5 plus x. And same thing with number 6. Okay, number 7. So if you go from the center and head toward a chord, and it makes a right angle, if it's perpendicular, then the chord is being bisected. Okay, because if you start at the center and draw a segment, that segment is going to be on the diameter. All right. And if a diameter is perpendicular to a chord, it bisects the chord. So if this is 10.6, this right here is also going to be 10.6. Now, we have a right triangle here. So use Pythagorean theorem. A squared plus b squared equals c squared. Okay, across from your right angle, that's going to be c. The other two sides, it doesn't matter which is a or b. So I'll let a equal 10.6. I'll let b equal 4.3. Okay, and you guys can finish that one from there. Just plug into the equation, take the square root at the end. Number 8, same thing. This is the center right here, and if you head toward a chord from the center and it's perpendicular, it's bisecting the chord. So this right here is congruent to that right there. If this is 8.3, this one is also going to be 8.3. Okay, use Pythagorean theorem again. Across from your right angle is always going to be c. The other two sides are a and b. 9 is easy. It's just Pythagorean theorem. They gave you all the stuff you need. Number 10 starts from the center, and it makes a right angle here. This chord is being bisected. If this is 10.8, then this one right here is also going to be 10.8. Okay, across from your right angle is going to be c. The other two sides, it doesn't matter which is a or b. So you can let x equal a, you can let 10.8 equal b. Use Pythagorean theorem right here. All right, number 11 is tricky because you have to draw in another radius. All right, this is the center, and this heads to a chord. This chord is being bisected. So if this is 15, this is 15. But that doesn't help us solve for x. So we actually have to find this piece right here. And no matter where you draw the radius in a given circle, it's going to be the same. So if this is 16.7, we can draw a radius from the center to this point right here. If this is 16.7, then this radius is also going to be 16.7. Okay, we need Pythagorean theorem right here. And across from your right angle is always going to be c. I'll make this piece here equal to a. And this side length here would have to equal b. All right, so please pause and try Pythagorean theorem right here. So, of course, we're using a squared plus b squared equals c squared. A we don't know, so we'll leave a squared as is. B is right here. That's going to be 15 squared. And C is right here. That's going to be 16.7 squared. All right, solving for a squared, the opposite of positive 15 squared is negative 15 squared. Okay, I'm going to do that to both sides. And it cancels here. A squared equals this mess here. And the way to get rid of the squared, the opposite of squared, is to take the square root. So you want to do that to both sides. Square root of a squared and the square root of this mess right here. Square root of a squared is just a. And this right here I'll do on the calculator. Okay, I get a big decimal. I'll round off to 2 places for now. And that's just going to be 7.34. All right. And now at this point it's easy, because we know that this plus this is going to equal this right here, okay, because this is a radius. So 16.7 is going to equal A, which is 7.34 plus X. All right, and you can solve for X from there and just round it off to 1 decimal when you're done. All right, number 12 is a little bit easier. I don't think you have to add anything to this. This is the center, so this is a radius. It's perpendicular. That means this piece is congruent to this piece. The chord is bisected. So this is going to be 12.8 right here. All right, if this is a right angle, this is also going to be a right angle. So solve for this side right here. Go across from your right angle, that's C. The other 2 sides are A and B. I'm going to let this equal A. I'll let the 12.8 equal B. All right, use Pythagorean theorem to solve for A. And then at the end, you're going to have this as a radius. A plus X is going to equal 15.1. Okay, but you can solve for A from this right triangle here and then complete this equation and you have X. All right, number 13, let's see. Center is here. It makes a right angle, so the chord's being bisected. If this is 14.1, this right here is 14.1. Okay, so we got that out of the way. And now let's see. If the entire diameter is 30, then the radius right here is just going to be half of 30, so that's 15. Okay, so go across from your right angle. That's going to be C. This side here, or the other 2 sides, it doesn't matter which is A or B. I'm going to let this one equal B, and I'll let this piece here equal A. Use Pythagorean theorem and solve for A. And then this here is a radius. A plus X is going to equal the radius, which is 15. Okay, and you can finish that one from there. Finally, number 14, this is the center. It makes a right angle. If this is 15.7, so is this, because the chord is bisected. Okay, so that's going to be 15.7. All right, let's see. If this is a radius here and it's 18.9, we can draw another radius right here. And that's also going to be 18.9. Okay, use Pythagorean theorem to get this side right here. If you go across from your right angle, that's C. We can let this side here equal A. We can let this side here equal B. All right, use Pythag to solve for A. And then you have A plus X, which is a radius. And we can see the radius right here going from the center to this point right here. That's a radius. So that's going to equal 18.9. And then you can finish that equation once you solve for A.